What all you got in there? You said chips? Oh. That might mean you gotta take them chips out. You brought everybody some chips? How many bags of chips you got in there? Get another school, yeah. Them gonna be the chips. Them gonna be the chips you get if I was to ask you for some of your stuff. You all can have a seat and log into Google Classroom and open this study guide. Homework. That's the next one. Watch your face while you're there. Morning, when you said when it's clear that they can go in and they come out.
Good morning, Ms. Kitchens.
Good morning. Mr. Walker said good morning.
Hey, Cedric.
Come on, Madeline's up here. Oh, what's the bathroom, right? Oh, your friend's still out here. And I can go up here. Okay, Crystal, wake up. You holding us up. Go ahead. Come on, Jordan. Yeah, paper. I teach math. Good morning again. Make sure I got everybody. I'm good. Good morning. What about you? Good. All right. Just try to open it up to the practice. If it load, okay. If it don't load, we math. Did everybody get your stuff when you came in? You got paper, pencil if you need it, calculator, blue, white. Good morning, those of you at home. Kennedy, Cedric, William. All right, so today we're going to go ahead and keep it moving. Today is Tuesday, March 2nd, 2021, 7 SP 8A, 8B, and 8C. I can find the probability of compound events with 65% mastery. Now, since last week, we've been looking at probability. How do we find probability? What have we been doing? What did we do yesterday? Okay, so we wrote it as a fraction, then we changed it to a decimal, and then we got good job. So that was just a one event. Now we're gonna look at compound events. Compound events are like two things happening. I flip the coin and I roll the dice. So now two different things. All right, as always, remember that you are a champion. All right, a few vocabulary. A sample space is a set of all possible outcomes for an experiment. We looked at some when I flip the coin, heads or tails, but now we're going to look at when I have those double events. It's known as a sample space. I already told us a compound event is more than one event. And then a tree diagram is how we can show that sample space. So that means instead of me thinking about it, I'm going to put it on paper and I'm going to see exactly what that sample space looks like. What could this sample space possibly be about? BG, what could that possibly mean? Boy and girl. First child was a boy or a girl. And then they tried, it looked just like yesterday. So that's why I put it up here. It's a sample space. If I didn't say this on yesterday, I'm going to tell you today. That last column will tell us how many total outcomes we have. So looking at that last column, how many outcomes will we have?
3 boys.
Just look at count. Just count. Just count. 1, 2, 3, 4. So I have an option of 4 outcomes. And then when I consider those outcomes, I still look from left to right. So if my first one was a boy, my second one is also a boy. That's one of my options, boy, boy. Or I had a boy, and now my second one can be a boy. So that's my second option. I had a girl, and it changed to a boy. And then I had a girl, and possibly another GG. So those will be the 4 outcomes. So if I look at the end, that's what it's going to tell me. My total, and we should know by now that total happens to be your denominator. So if they ask me for probability, I'm going to go ahead and put 4 as their denominator. Any questions about what does it look like? Good morning, Stuart. All right, did you practice load or still struggling? All right. Yes, it should say March 2nd. All right, number 1 says Charlotte is playing a board game. To move her game piece, she needs to roll the same number on 2 number cubes. What does she have? We on number 1. I said to move her game piece, she needs to roll the same number on 2 number cubes. What is she using?
Tree diagram.
Okay, Thank you. Two number kids. We ain't looking at two. We at number one. They said Charlotte is playing a board game to move her game piece. She needs to roll the same number on two number kids. Where you see a diagram at? They got a whole lot out here right now. When they finish, come on. Hey, ready? All right, now they say represent the sample space and find all the ways she can roll the same number. So let's stop and think. A number cube. How many numbers are on a number cube? If you got a number cube, those are die. How many numbers are on the die? 6. So I know my first option would be 1 through 6. That's my first choice. I'm gonna either write on 1, 2, 3, 4, 5, 6. All right. Now I roll that number cube again. What are my options? So that means every number now should have those same options. Notice they all getting the same thing. I haven't done nothing different with none of them. So that's what they mean when they say represent the sample space. That's what that sample space will look like. I had 1, 2, 3, 4, 5, 6, and then my second option, I'm also get 1, 2, 3, 4, 5, 6. They then told us we need to find all the ways that she can roll the same number. All right, with that sample space, that's telling me I could have had a 1 and a 1. I could have had a 1 and a 2, a 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, and so forth and so on. So what instance could I have had the same number? Looking at that sample space, when is the chance that I would have had the same number? I'm gonna give you 1. If I rolled a 1 and a 1, that's the same number. 1 chance? No, that's just for that set. We got 6 things up there. That's all the time I had the same number. Could have had a 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. How many opportunities is that? 6. How many total do we have? Count your bottom or multiply. You do this multiplying 6 times 6. 36. Can it be simplified? All right, what is it simplifying to?
26.
Good job. Any questions about what we did? Wrote the sample space, and then sample space will easily help you see how many times you're going to get the probability they ask you for. I already draw the sample space, so you will see what you need to know. Go back. All right. And I'm going to leave, well, one going to stay up while we looking at 2. All right, it says Kayla has a bag with an equal number of red, yellow, and blue marbles. They said she makes a tree diagram to show the sample space if she randomly selects 2 marbles out the bag. Bless you. They then asked us, what is the probability that both marbles selected a different color? So notice her diagram. We only got 3 things in this bag, so those are her only 3 options, red, yellow, and blue. She pulled 2 times. So that's why they did the first row and then the second row, because she pulled 2 times. But that second pull, she still got those same options, red, yellow, or blue. Same thing. So now they ask, what's the probability then both marbles are different colors. So let's see how many times when we have different colors. Is red different? What about red and yellow? What about red and blue? Yellow and red? Yellow, blue? Blue and red? Blue and yellow? Blue and blue? How many check marks we have? How many total did we have? 9. Simplify it. Not 1. 2/3. Somebody divide it out. Check that. 2 divided by 3. 6 repeats, so 67. So then you got 67%. So there's a 67% probability that she will select 2 different colors. 67%. Any questions about what we did for 1 and 2? Anybody see a need anything? Let me know what you think about it. Y'all let me know what you think.
Oh, I got it on my paper. I was just translating it.
Yeah. You got on your paper to transfer it? All right, number 3 reads, a coin is tossed 3 times. Draw a line from each outcome to its probability. Is that something I can just think about? No. I'm gonna draw me a sample space to make sure I get those correct values. So on my first flip, what are my options? Heads or tails. They told us we got a coin. All right, my second option. What could I have? Good job. So that means each one, notice how each one is being broken apart into 2. That's why I say go ahead and stick them on, or you gotta go ahead and fill them in. So then my third option, I will still do the same thing with heads and tails. Remember, each one breaks apart to give your options. Any question about what we did? All right. We're gonna also write that sample space. So the first one I would have heads. And I'm gonna just write them over here. Then I would have heads, tails. I could have had heads, tails, or heads, tails. Good job. Tails, heads. Tails, heads. Tails. You missed the head, but I get your tail. Good. All right, how many total options do we have? 8. So keep that in mind, because if that's our total, that's going to be our what? That's our denominator. We got 8. All right, so let's look at the probabilities they said. The first one, they say 3 heads. How many times do you see H? Only 1 time? So what's our probability? What do we see our denominator was? 1/8. You said it was only 1. All right. The second one says exactly 2 tails. What's it? Yes. I thought you didn't want to go. Oh, I'm sorry. Exactly 2 tails. 2 tails. Okay, I'll go with tail, tails, H. Head, tails, tails. Okay, THT. Any others? All right, so how many we have in the pink? And we said that the denominator is? Good job. All right, now notice this one. It said the first 2 tosses are heads. So that means the first 2 need to be heads. Okay, the second one. First 2 heads. That's the only one you see with the first 2 heads. It'll count because it got the first 2 that's a head. All right, so how many do we have? 2. The denominator is 8. Can 2 8s be simplified into what? Good job. And then they said at least 2 tails. For exactly, we had 3. And so this last one, we need to add in the last tails. So now we have 4 8s. And 4 8 simplifies to what? Good job. Any questions about it? Write your sample space and then your probabilities. I say 3 heads was equal to 1 4. So you can't actually draw the line in the box. Any questions about it? Y'all sure? All right. Anybody still getting anything you need? Okay. Anybody else? All right. Andy is randomly selecting an outfit to wear to school. He chooses from 4 shirts: blue stripe, red stripe, black stripe, or white. He can choose from 3 pair of pants: tan, blue, or plaid. And then they want us to answer true or false. Just like last time, if I'm looking at sample space, I'm gonna draw me a tree diagram. So the first thing we're talking about is shirts. So that's blue stripe, red stripe, black stripe, and then white. What option do I have for shorts?
Blue shorts, black shorts,
Tan, blue, plaid. And that'll be the same for all of them. Tan, blue, plaid. Tan, blue, plaid. And then again. Any questions about the sample space? A says there are 7 possible outcomes in that sample space. 7 possible outcomes. Where can I look to see my outcomes? All right, look on the second row. How many we got? So I would say false. There are 12. Number 2, the probability that Andy chooses a striped shirt and a pair of blue shorts. Striped shirt and a pair of blue shorts. Somebody give us our options. What can I choose? Say it loud. All right, blue stripe with blue. Somebody said red stripe with blue. And black stripe with blue. Do I want white? Hello? Yeah, they going in and out. Do we need white? All right, good job. It's not striped. So how many do we have circled for striped and blue?
3.
And we said our total was 12. Somebody figure out 3 12s. 3 divided by 12. You doing 12 divided by 3. All right, good. So that would work. All right, C asked us, they say there are 3 ways to choose a red striped shirt and a pair of plaid shorts. 3 ways: red striped shirt, and plaid shorts. How many times can we possibly get red striped and plaid? How many? One time. So that would be false. It's only one way. All right, and then D says the probability that Andy chooses a striped shirt and a pair of tan or plaid. Striped shirt, tan, or plaid. 3, what your name your 3. All right, then they gave us some specifics, tan, plaid. So do your blue stripe with tan, blue stripe with plaid, and then do the same for red stripe, and then with black stripe. So now, how many we have in the blue?
3.
Look again.
Oh. Wait, yeah, I'm pretty sure it's 3.
Look again, William. I don't know if you can see my whole screen.
Oh, 2.
We had to count all the, you gotta do that for each one. So you should have had 6. All right, and 6 12, what does it simplify to? 0.5 or a half, that would be true. Any questions about it? So the main thing to see, if I need to draw a sample space, I'm definitely gonna draw it to help me get the correct answer. These be the questions y'all will look at and we'll just choose true, false, and we ain't thought about it, hadn't drew nothing, but we'll have an answer. All right, anybody still need anything? Okay. All right, it says a cereal company puts a toy car, a toy bus, or a toy airplane in each of these boxes. The company says 20% of the boxes will contain a car, 40% a bus, and 40% an airplane. Jeffrey designed a simulation to explore how likely it is to collect all 3 toys if he buys 3 boxes of cereal. He assigned digits as follows. 0 or 1 represent a car, 2, 3, 4, 5 represent a bus, 6, 7, 8, 9 represent an airplane. Then he generates the following sets of random numbers for his simulation. Based on the results of the simulation, what is the probability that Jeffrey will collect all 3 toys if he buys 3 boxes of cereal? We need all 3. The first one told me I at least need a 0 or 1. What can I eliminate because it don't have 0 or 1? You got a 1. 9, 8, 1. Somebody said
2, 7, 4, 2, 7, 4.
476, 274, 385. All right, that look like all of them. All right, so let's look again. Now they said we need 2, 3, 4, 5. What can I eliminate? They got a 3 in it.
Oh.
You got a 5. You got a 2. 5, 2, 1. They got 2 and a 5. Keep everything. Okay. The next one they said 6, 7, 8, 9. Okay. Okay, 5, 5, 0. Good job. 5, 2, 1. That's it. All right, how many we got left? 5. How many total did we have? All right, somebody simplify 5 15ths. 1/3 as a decimal, 0.33. So 33%. Any questions about it? Y'all sure? You said what? That's the only thing what? You gotta put this whole school in there. Come on. Got children out there. Girl, you better knock out, got you out there. One of the easiest things we're doing 7th grade. That's what the other class noticed. They're like, oh, Miss Country, we can do this. Anybody still need something? All right, it reads, at a restaurant, a children's meal gives a choice of 4 entrees, burger, chicken, pizza, spaghetti, and 2 sides, apple or fries. Which sample space represents all the ways a child could choose 1 entree and 1 side for his meal? I want you to stop and think about it. Which one would show us all the ways for his options? You can draw your graph. Stop and think about it. Which one will show us all the ways for those options? Huh? 4. What's your 4? I need more specific. You're confused. Which word is your word, and I'm sure. All right, so give me one of your options you're talking about. Okay, burger and fries. So we know we need burger and fries. All right, what else could we have? A burger or what else? Burger and apples. So we need a B and A. So that means A will be our correct choice. Burger and apples, burger and fries. Then they told us apples, chicken and fries. I got no key in this class. I don't believe. And then they told us we could have pizza and apples, pizza and fries. And then spaghetti and apples, spaghetti and fries. A would be correct answer. So if you don't do the sample space, Or you could have did it. I probably would have did B, apple fries. And I would have did the same with C, pizza, spaghetti. Apple fries. Apple fries. Apple fries. And then, of course, I'll write it out. B-A, B-L, C-A, C-L, so on. B then says the restaurant decides to add another choice for the entree and another choice for the children's menu. The extra entree is grilled cheese. The extra side is mixed vegetables. And they want us to give a probability. So before I move on with that, I'm going to look at what I already have. We now got another side option, which is mixed vegetables. We're going to label that as M. So if I had burger and apples and burger and fries, I now can have a burger and what? Chicken and apples, chicken and fries, I now can have chicken and apples, chicken and fries.
Chicken and mixed vegetables.
Good job. Pizza and apples, pizza and fries.
Pizza and mixed vegetables.
Spaghetti and apples, spaghetti and fries. Good job. Another entree they gave us was grilled cheese. So now I can have grilled cheese and apples. What else?
Grilled cheese and fries.
Good job. So now, how many total options do we now have? All that, the whole row. 15. They told us, all right, and that's 8, 9, 10, 11, 12, 13, 14, 15. All right, they told us the probability that a child would choose pizza or spaghetti with mixed vegetables. Do we see it? Pizza or spaghetti and mixed vegetables.
Yeah. Right there.
Like, give me the levels, Charles.
P, P, and M.
Okay. S and M.
I mean, S and M.
All right, any others? That's it? How many we chose?
2.
2? 2 out of 15. Somebody divide it out for us. All right, 13. So that'll be 13%. Any questions about finding that sample space? Any question about looking at that sample space to answer questions? You sure? All right. Anybody still need something? Okay, let me know you finished, Kamora. You got it? Anybody else? Okay, dokie. All right, it says Sophia asked each dinner guest to select one choice from each list. The main list, chicken, salmon, or steak. The sides, potato or rice. And then we got some vegetables, beans or broccoli. The first thing they say is model the sample space with all possible outcomes. Model the sample space with all possible outcomes. All right, so if I get chicken, what can I get with chicken? Potatoes or rice. So I got chicken and potatoes, chicken and rice. What else can I get after I choose potatoes and rice?
Beans
Beans
and broccoli.
and broccoli. So now I'm gonna do that again. Chicken and potatoes with beans, chicken and potatoes with broccoli. And then I got chicken and rice with beans, and then chicken and rice with good job. So then if I have salmon, it's gonna work the same way. Salmon and potatoes with beans. Salmon and potatoes with rice and beans. Salmon and potatoes with broccoli. Good job.
Then we got steak.
Hold on. No, that should have been salmon and rice and broccoli. Good. All right, and then we got steak, potatoes, and beans.
Steak, potatoes, and rice.
Steak, potatoes, and broccoli. Somebody said steak, potatoes, and beans. Steak, rice, and beans, and now steak, rice, and
Broccoli.
good. All right, the second part of that, it said, find the probability of a guest requesting either potatoes or beans if the guest chooses a random. Potatoes or beans. Give us some that got potatoes and beans. Just read the whole thing to us. Run after this.
CP.
Chicken, potatoes, and beans. Salmon, potatoes, and beans.
Okay.
Steak,
Steak,
potatoes,
potatoes,
beans,
steak, potatoes.
and fruit.
That's all the potatoes?
I mean,
Steak, potato, and broccoli.
Do this wrong, we got potatoes. That's all with beans?
No, it's the second though.
Remember, they gave us two options, so that means I'm looking for all my potatoes, and then I'm gonna look again to get everything that had beans. All right, how many do we have? 9. How many total did we have?
12.
9, 12. 75%. Good job. Any questions about it? Y'all sure? Let me know what you think. All right, anybody else? You talk. All right. All right, number 8. Leo and Paul each have 5 cards. Leo's cards are numbered 1, 3, 4, 5, 5. Paul cards are numbered 1, 2, 3, 4, 6. Without looking, they choose one card to show, and the greater card wins. Make a table and list all possible outcomes. All right, so I start us off. If I'm Leo, I could have chose 1, and Paul would have had what? 1. Leo could have had 1, and Paul could have had what? You skipped 2. So y'all still looking at Leo. We still on Leo. This is what I mean. If I'm looking at 1, I'm gonna make sure everything down here goes to 1 first. So we got 1, 1, 1, 2, 1, 3, 1, 4, 1, 6. Good. Now I'm Leo, and now I got 3. Good. 3, 1. Good. 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 All right, keep going.
4, 1, 4, 2, 4, 3, 4, 4, 4, 6.
Good job. Keep going.
5, 1, 5, 2, 5, 3, 5, 4, 5, 6. And the same.
And then the same. And remember, they told you to make a list, so type that in there somewhere. Make sure you got it somewhere so we can see it. All right. The second part of that said, what is Leo's probability of winning? Now, remember, they said we only win if we have the greater card. Leo is the first number. Leo is the first number. So give me a set where that first number wins or beats the second number. I'll start us off like 3, 1,
5, 1,
5, 1,
5, 4,
4, 3,
5, 2,
5, 3,
5, 4.
That's it. All right, how many do we have circled? All right. I verified it. 8, 9, 10, 11, 12, 13. How many total do we have?
25.
All right, 25. Somebody give us that percent. 13 out of 25. 0.52. So we know that's 52%. That's Leo. So that means Paul would be the opposite. So Paul's chance of winning, if Leo had 13 out of 25, how many Paul got? What? Our total is still 25 now. Take 25 and subtract 13. So that means he got 12 out of 25. Somebody give us that percent. Good job. So 48%. Remember, if we're talking about two things, when I finish, both of them together should give us 100%. So Leo has a chance of winning 52%. Paul has a chance of winning 48%. Uh-huh. Yes. All right, let me know when you finish. All right, anybody else? All right, it says, when rolling two number cubes, what's the probability of rolling at least 1/6? Don't know neither one. All right, think about what they said. What are we rolling? Two number cubes. So that go back to what we did in the beginning. Remember that first set we had where we did 1, 1, 1, 2? Y'all remember? I'm gonna do the first one. And then of course that would have went the same for all of them. So they want to know at least, well, let's go ahead and put them. That'll help us clearly see it. So then be the same. And then last but not least, that last flip. All right. So those will be our sample space. So that means if you come across questions that you need to do a sample space for, I would strongly encourage you to list them out real quick before you try to choose an answer. All right, so now let's see what they asked. And they said rolling at least 1/6. All right, 36 is our total, so that's our denominator. All right, give us some numbers. Rolling at least 1/6.
6.
6, 6.
3, 6.
6, 5.
6. Yeah, that means every time I see a 6 on the left or the right, I'm gonna choose it as an option. All right, so how many do we have? Look again, that's 6 on that row. All right, I hear 11. Good. Our correct answer will be B. So that means if you need to draw a sample space before you try to choose an answer, please do so. It'll take us 3 seconds to type out how many options I'm gonna have, and then I'm gonna choose my answer. Any questions about it? Anybody still need something? All right, let me know you finish. I'm on top.
Miss Hutchins,
Huh?
how many we got more?
I'm not sure. Somebody scroll down real quick.
So we got like 3 more.
3 more. 3.
Okay.
You got it, Tyler? All right, 3 cards, one labeled A, one labeled T, one labeled C are picked in random order based on the tree diagram, which is a valid conclusion. Select all that applies. So they already gave us a tree diagram. Now let's see. Answer choice A says the probability of the letter spelling cat. How many times would it spell cat? That means look across. So that would be A-C-T, A-T-C. So which one could I get? C-A-T. One in the middle.
C-A-T, with the C-A-T, with the C right there.
Okay, so that don't count. All right. How many options would that be? Out of how many total? Good job. Count the N. That's all we're going to tell us, how many total options. So that'll be 6. All right, part B asks the probability that T will be the first letter chosen. Be more specific. Read it to me. T-A-C. That's the only one that starts with a T. So it looks like we need to write them out. A-C-T, A-T-C, C-A-T. What's next? C-T-A, T-A-C. What's next?
T-C-A.
Okay, so how many times did we start with the first letter being a T?
2.
That means if I need to write it out, make sure I write it out. Can 2, 6 be simplified? Good. So now we see why that one works. So make sure y'all got to look carefully. All right, it says the probability that A will be the first letter. Twice. So that would have been the same as this one, 2/16. So clearly that's not 1/15. They said the sample space consists of 6 outcomes. Yes, we got 6 letters over there lined up. It says 15 cards must be drawn to determine the probability of spelling a cat. Clearly not. So you should have A, B, and D. Any questions about it? All right, everybody got that one? Tyler? All right, we got 1, 2, you got 3 left. Can't open that door. That way I can see when she moving. Huh? The last one always tell you to upload. Last one always say upload. Yes. All right, we're gonna go ahead and keep moving with this one until Ms. Jackson get about ready to move. I think that's her moving now. All right, a 7th grader got 2 siblings. Model the possible orders for genders of a family with 3 children. All right, what are my options for a child? Good job. The second child. I'm gonna still go boy, girl. Do not go out of order. You're gonna get yourself confused. So then if I got 3 children, guess what? I'm gonna do it again. Boy, girl, all the way down. I like to keep that same pattern. When I start going against the pattern, that's when I do something different. All right, how many possible outcomes? Read the end, look at the end, count every letter on the end.
14.
All right, it said, what's the probability that the 7th grader is a girl with a brother and a sister? So that means 2 girls and a boy. How many times do I see 2 girls and a boy? GGG, that's all girls.
GBB. G, wait.
BGG. I also could have did GBG. All right, how many options would that be? 3? 3 8. Somebody divide it out. 37.5%. Good. All right, it said the probability of at least 2 girls. GGG. BGB. BGG, okay. Got it. And now we'll do GGB. All right, 4 out of how many? 8. Simplifies to a half or 0.5, 50%. And then it says name an outcome with a probability of 1/8. What up there I can only get one time? One time. BBG.
BBB.
BBB, all boys. Or GGG, all girls. All right, go ahead and finish getting what you need for that one. We'll stop right there. So that means you may have 2 more. As always, if I know I'm not gonna go back and submit, I need to go ahead and submit it now. Make sure you do your best at typing your sample spaces in the box. You can't type it in, take a picture of it and put that with it. Get what you need, you can begin to read them. Nobody asked to know what they missed on yesterday, so I'm taking we know we missing for math. We just gotta get it done. Malone is on the way up. All right, don't you at home, 7th graders. Have a good Tuesday. See you later.
See you tomorrow, Miss Kitty.
Have a good day.